Hello everyone. This is in continuation to our topic learning curve. This is comprehensive numerical problem number 4. The organization to which you belong is a regular supplier of Indian Railways. Submission of bids against various tenders is a regular affair of the firm. As a part of the organization's costing department, your job is to help the department who are dealing with these bids by calculating the cost. Recently, there is a limited tender for supply of 1600 pieces of a product, which is somewhat new to your organization. Indian Railways want supply of batches of 100 at a time. It has been estimated that the average cost of the first batch of supply is rupees 100 per piece. 90% learning curve applies to the cumulative labor cost on this contract. On the basis of the information above, prepare an estimate of labor cost for the full contract. Second part, as per the tender, a supplier will be awarded with another order of 800 pieces after the successful completion of supply of the first 1600. Find out the incremental labor cost for producing an additional 800 units. So this is the question. So if we look into this, we may understand we will be definitely using our what we call learning curve model, which is y is equal to a x to the power of b. Here, our a will be cost of producing first batch. That is given here. Indian Railways wants the batches of 100 at a time. That means first batch will be having 100 units. And per piece, it is going to cost rupees 100. That means it is rupees 100 multiplied by 100 pieces. And that will work out to rupees 10,000 for the first batch. Then X will be the initial order is for a limited supply of 1600 pieces, which means X is, I'll convert this into number of batches, which is 1600 divided by 100. So it is 16 batches. Then our learning index B will be logarithm of learning percentage divided by logarithm of 2, both to the base 10, which is logarithm of 0.9 divided by 0.301. So for logarithm of 0.9, we will do separately. That can be written as 9 by 10. So that can be simplified as log 9 minus log 10, which is log 3 square minus 1. Log 3 square can be written as 2 log 3 minus 1. So that is 2 times 0.4771, because we know log 3 is 0.4771 minus 1. If we calculate this, we will get negative 0.0458. So therefore, our B value will be negative 0.0458 divided by 0.301. If we calculate this, we will get negative 0.1522. Therefore, Y will be equal to A, that is 10,000, times X, which is 16, to the power of negative 0.1522. Now, let us assume K as 16 to the power of minus 0.1522, which means logarithm of K will be negative 0.1522 times logarithm of 16. So this can be further simplified as negative 0.1522 times logarithm of 2 to the power of 4. So therefore, logarithm of K will be negative 0.1522 times 4 into logarithm of 2. So that will be negative 0.1522 multiplied by 4 multiplied by 0.301. So if we multiply all these values, we will get negative 0.18325. This means that K will be antilog of negative 0.18325. Now, to calculate antilog using our regular calculator, we will first type the number, that is minus 1.8325. Then we will multiply that by 0.1234544. 5 zeros after decimal point and then 44. Then we will add 1. We will get a result as 0.999999, means 6 nines and then a 2. Then we will enter into equal to 19 times in the regular calculator. If we do that, we will get 0.655255 as the result. Therefore, our y will be 10,000 times. This is our k. This is our k basically. So k value, we already defined it as 16 to the power of negative 0.1522. So instead of that, we will replace it with 0.655255. So if we calculate, we will get rupees 655 to 0.55. This is per unit cost. Sorry, per batch cost. Therefore, for 16 batches, the total cost will be equal to rupees 6,520, sorry, 6,552.55 into 16. 6,552.55 into 16. That will work out to rupees 104840.80. This is the first part of the question for the full contract. Now, as per the tender, additional award, additional quantity will be awarded, mean additional order of 800 pieces. So we can now, since it is additional after 1600, we'll now work out for 1600 plus 800, which is 2400. Part B, we will consider X equal to 24 batches. How 24? It is 2400 divided by 100 on that basis. Then Y will be 10,000 times 24 to the power of negative 0.1522. Now let us consider this 24 to the power of this thing as C. 24 to the power of negative 0.1522, which means logarithm of C will be negative 0.1522 times logarithm of 24. That is nothing but logarithm of 8 into 3. 8 is nothing but 2 cube. So this we will write it as logarithm of 8 plus logarithm of 3, which is negative 1.152 multiplied by log 8 is nothing but 2 cube. So that I can write it as 3 log 2 plus log 3 is 0.4771. So this will be negative 0.1522 times 3 into log 2, which is 0.301 plus 0.4771. So if we calculate this entire thing, we will get negative 0.21005. So therefore, C will be antilog of negative 0.21005. Now, to find out antilog of this, type this number in a regular calculator, multiply it with 0.5044, then add 1, we'll get the result as point. Let me once again do that. Just a minute. Negative 0.21005 multiplied by 0.12345, 5 zeros, 44, and then adding 1, we will get 6 nines, and then 1, and then 1. Then to this number, after this, multiply equal to 19 times we have to enter. When we do that, we will get the result as 0.616. Therefore, y will be 10,000 multiplied by 0.616. We will get rupees 6160 per batch. Therefore, for 24 batches, cost will be 24 multiplied by rupees 6160. We will get rupees 147832.70. Now, therefore, the incremental labor cost will be the difference between these two. 147832.7 minus rupees, the previous amount is 104,840.8. 104,840.8. If we subtract these two, we'll get approx 42,992. That will be the solution for this particular question.